I decided to work a few concentration of solution problems out for you, hopefully help you, since the test is coming up pretty quickly and we really didn't have much time in class to go over them. So what I'm going to do is I'm going to give you some problems like I've written out here, and then what I want you to do is pause the video and try to work it out yourself, and then on the next page I'll work it out for you so you can check your answer if you get stuck. The first thing I recommend doing when you're trying to solve a problem is look for the concentration units that you're dealing with and its molarity. Then write out the equation for molarity, because that will help you solve it. So molarity is moles of solute over liters of solution. And typically, a problem, so you see you have three variables here, molarity, moles, and liters. So typically a problem will give you 2 out of those 3 values, and then you can solve for the unknown third value. So what do they give you here? They give us molarity, which is 2. They don't give us moles, so there's our unknown. Moles of solute, which we know is calcium nitrate. And they give us liters of solution. Okay, 867 milliliters. It's got to be in liters, so you need to convert that to liters by dividing by 1,000. Okay, so now you want to solve for moles of calcium nitrate. So moles of calcium nitrate equals 2. Multiply both sides by 0.867. Okay. And that means the moles would equal, let's see if I multiply by 2 in my head. Okay, 1.734 moles of calcium nitrate. The problem, however, is asking for the mass, which is grams. So now you need to convert this mole to grams using the molar mass, which I was nice enough in this problem to give to you. So multiply by molar mass. Okay, cross out moles, you'll get grams, and I do need to put that into my calculator. So your final answer, I gotta write smaller, I guess, is 284.5 grams of calcium nitrate. That's how many grams are present in 867 milliliters of a 2-molar solution. That problem is easy to middling, okay, just to kind of give you an idea of what level of difficulty to expect on the test. I like this problem because it asks you to calculate based on 2 different units of concentration. So this happens to be ethanol, which I wouldn't expect you to know, but a solution of ethanol is made. All right, so I'm going to go ahead and give you the formulas for both of them and then work it out on the next page. I will give you, if there are more complex formulas, I will give those to you on your test. I'm not going to give you the very simple ones like molarity, molality, and percent by mass. Those are things you really need to know. So molality, but I'll give it to you now, is moles of solute. So the numerator is the same as molarity. It's the denominator that's different. So molality is kilograms of solvent. All right. So percent by mass is grams of solute in the numerator over grams of the entire solution in the denominator times 100. Now, this may seem obvious, but just to remind you, what is grams of solution? It's grams of solute plus grams of solvent. That's what the solution is. It's made up of solute and solvent. So you've got to find each of the masses of the 2 components and add them together for the denominator. So just as I said for problem number 1, write out the formula and see what you can plug in from the information given. So we're going to do part A, which is molality first. And let's see, what did they tell us? Do we know the moles of solute? Well, the solute is ethanol, and we know the grams. We have 14 grams of ethanol. Okay, and so we can get moles, right? We just have to divide by the molar mass of ethanol. So the molar mass of ethanol is 46.07 grams per mole. So I've got to plug this into my calculator. And so the moles of ethanol present in the solution, 0.304 moles. Okay, and so that'll get plugged in there. And how about kilograms of solvent? What do we know about the solvent? They told us that there were 100 grams of H2O, that's our solvent, and so we just have to put that into kilograms. So there are 1,000 grams in 1 kilogram. So that means that this 100 grams equals 0.1 kilogram. So now we can solve for molality, which is a little m. So we know that we have 0.304 moles, and we have 0.1 kilogram. And so the molality equals, 3.04. Put a little m, stands for molal. That wasn't too hard, was it? So let's go ahead and do part B now, which is the percent by mass. I'll do that on the next page. So this one's going to seem pretty easy too. So the percent by mass of the solution, we're flat out given the values we need. So the mass of the solute is 14 grams, goes in the numerator. And the mass of the entire solution is simply mass of solute and solvent added together. So the entire mass of the solution is 14 grams plus the mass of the solvent, which is 100. Okay, times 100, whoop. And so percent is 14 divided by 114 times 100. So the percent by mass ends up being 12.3%. Okay, so that tells us there's 12.3% ethanol in that aqueous solution. So now I'm going to do a couple problems that are a little bit more difficult than these first two. All right, so this is a classic dilution problem where they give you the concentration of, call it a stock solution, in this case 10 molar, and they're taking some of that, in this case, well no, they're just diluting this. They're just adding more water to it. So it's asking for the new concentration. So go ahead and try to work it yourself, and I'll have it worked out on the next page for you. I'm going to show you two different ways of working this problem out. The first thing to do is I always say it's molarity. So go ahead and write your formula out. Molarity is moles per liter. And let's see, which of those values do we have so far? Let's see, the original solution, so let's forget about the dilution for now. The original solution, they said, was 10 molar, so we have that. And we have 50 milliliters of it. So we don't know how many moles are in that 10 molar solution, but we have 50 milliliters, and 50 milliliters is equal to, move decimal over 3 places, 0.050 liters. All right, so this is the two, we always know 2 out of the 3 values in the molarity equation, and so we can solve for how many moles we're dealing with. multiply both sides of that equation by 0.050. Okay, so then moles would equal 10 times 0.050, and that equals, ouch, my dog just sat on my foot, 0.50. Okay, that's moles. That was how many moles we have in 50 mils of the original solution. So now we're trying to figure out the new molarity. We just found out that in the new solution we have 0.50 moles. What is the total volume of the solution that we have at the end? Well, we started with 50 milliliters, 0.050 liters. And remember the problem said we added 20 more milliliters to it, okay, which equals 0.020 liters. So our new molarity is 0.50 divided by 0.070. And that equals 7.14 molarity. Now don't lose your common sense when you do this. The original molarity was 10 molar. You added water to it, so you expect the molarity to go down, and it did. So that's good. I'm going to work the same problem in a more simple way, but I wanted to work it out step by step first so you can hopefully kind of visualize what's happening. But on the next page, I'm going to show you a simpler way to work dilutions. All right, so there is something called the dilution formula. Some of you may already know it. If you were in class the other day, I went over it. Okay, and it is M1V1 equals M2V2. So anytime you have a problem that gives you one concentration and volume and asks you to solve for a different concentration, you can use this formula. Big M's, they're both the original molarity and the new molarity, the original volume and the new volume. So I just want to show you how easy it is doing it this way. So our original molarity was 10 molar. They told us that we used 50 milliliters of it. Okay. They ask us to solve for the new molarity, so we don't know what M2 is yet. And the new volume, this is the tricky part. Some people would try to write 20 milliliters as a new volume. No. 20 milliliters is what we added to the original volume. So read the problem very carefully. All right. Solve for the second molarity. I'm getting lazy with sig figs now. And so then you would get the same answer. Yeah, 7.14. Okay, so work it however you prefer, but the two different ways of working the same thing. I think this type of problem is the trickiest. And that's because it asks you to convert from one set of units to another set. So they gave you molality and asked you to convert to molarity. So I'll give you a little hint and then I'll work it out on the next page. But let's write out what molality means. 3.296 molal means that there are 3.296 moles of the solute, which is fructose, in 1 kilogram of, what's the solvent? Water. We assume it's water unless you're told otherwise. Okay, that's what we know. We want to find out, no, that's not equals. We want to find out the moles of fructose, which we know. Yay, they're the same for molarity and molality. Over, now we need liters of the entire solution. Okay, so trying to find molarity, you know the moles already, 3.296 moles. What you really need to find is liters of the entire solution. Give it a try, and I will have it worked out on the next page. This is where it gets tricky, so you're going to have to listen carefully. So our concern with this is to get the denominator from terms of molality, which is kilograms of only the solvent, into liters, that's a volume measurement of the entire solution. So again, anytime you see solution, that means solute plus solvent. And remember, kilograms is only for solvent. So the first thing we need to do is find out how many grams of solute we have and add it to the grams of solvent. So we don't have grams of solute directly, but we do have moles of solute. So the moles of solute, if you go back to the original molality they gave us, it was 3.296. So 3.296 moles of fructose times the molar mass, which is 180, and I gave that to you, 0.16 grams per mole. That will give us the grams of fructose we have in 1 kilogram. So let me punch that in my calculator. And that gives us 594 grams of fructose in 1,000 grams of solvent. So the total mass of solution, and again, I'm trying to get a quantity of solution because that's what's required by molarity, is 1,000 plus 594. Okay, it's solvent and solute. Total mass of solution is 1,594 grams. Okay, that's nice. We've got grams. What do we need for molarity? We need liters. How do we get from grams to liters? Okay, so that's what we're trying to do. Anytime you're going from mass to volume or vice versa, you are going to use the density of the solution as a conversion factor. This problem gave you the density, and it is 1.203 grams per milliliter. So the density always tells you how many grams in a milliliter, so you can use it as a conversion factor. So if we have 1,594 grams, just set your conversion up, and there are 1.203 grams in 1 milliliter. And plug that into your calculator. Let's see, so there are, 1594 divided by 1.203. 1,325 milliliters, that's a comma, of solution. All right, now we've done so many calculations, let me remind you what we're trying to do. We're trying to find molarity, which is moles of solute over liters of solution. The moles of solute, keep having to look back there, 3.296. And the liters of solution, all right, we have milliliters. So convert that to liters. 1.325 liters. This is moles. So plug that back in to the calculator. And let's see, 3.296 divided by 1.325, 2.49 molar. Yay, I got it right. Okay, and so what was the molality? The molality, little m, that was originally given us was 3.296. Okay, that's it for that. I'm going to do one more problem worked out, another conversion. All right, I'm going to emphasize at this point how important it is for you to force yourself to try to work through. Even if you're not quite sure what you're doing, give it a shot, because that really is how you work best. You can watch somebody else work problems for hours and hours and hours and say, oh yeah, okay, that makes sense, but until you try to suffer through it on your own, you're not really going to learn at the level you need to. So, all right, off my soapbox. Please give it a try at your own, and I will work it out on the next page. So the first thing to do, as always, is to write out the formula of what you know. So you were given that there's a 60% by mass, all right? What exactly does that mean? That's usually the key to doing these conversions that involve one unit to the other. 60% by mass, it's of ethanol, that's the solute, means that there are 60 grams of ethanol in 100 grams of total solution. So a student asked me when I was showing her, she goes, how do you know this? Well, that's what percent means. Percent means how much of something is there out of 100. That's the definition of percent. So that's how I know that. So we're trying to go from this, which we know, 60 grams of ethanol and 100 grams total solution, to molarity, which is moles of ethanol per liters of total solution. So the good news is, in this problem, we're going from total solution to total solution. So that's good. So we just have to get from grams of total solution to liters of total solution. And remember, I said anytime you're going from mass to volume or vice versa, you use density as a conversion factor. So, and the density will always be given to you. That's not something you could ever know on your own. And so the density is 0.8937. There are 0.8937 grams of ethanol in, or of the solution, in 1 milliliter of the solution. And so just set up your unit cancellation. 100 grams of total solution. There are 0.8937 grams in 1 milliliter. And 100 divided by 0.8937 is 112 milliliters. Okay, so 112 milliliters. If we're going to do molarity, we need to have that in liters. So 112 milliliters divided by 1,000 is 0.112 liter. So we're getting closer. So what do we know so far? The molarity, we still don't know moles of ethanol. We have to calculate it. But now we know the volume of the solution. Okay, so we can certainly easily find the moles of ethanol. So let me do that on the next page because I've run out of room. So we have 60 grams of ethanol, and you were given the molar mass, and it is 46.07 grams per mole. And so that means the moles of ethanol that we have is 60 divided by 46.07. We have 1.30 moles of ethanol. We're about done. So the molarity of this solution is 1.30 moles divided by 0.112 liters that we just calculated on the last page. And so the final molarity is 11.6, put a capital M, and that is it. So there are lots more practice worksheets in the in-class worksheet or in-class problems folder in the content section of D2L. So please practice, practice, practice.